right, let's get started with this business calculus. So what is calculus? When you studied algebra, you studied constant conditions, where calculus is more changing conditions, which to me makes sense, right? Because things change every day. The stock market's changing, the economy's changing, real estate, interest rates, everything is changing. And that's the big difference with calculus being the difference of change, where what you've been used to is the algebra where things are not changing. So what we're going to end up doing is we're going to look at finding slopes of curves, because remember, slopes are a rate of change. So if I know the rate that prices are increasing per day, okay, something like that, if I can find a rate which is a slope and they're increasing this, not a constant, a linear way, I can make it linear by zooming way in until I get so close enough that I'm actually to a line. This stuff is used everywhere. I know it's difficult when you're in college, and if you haven't done this in the real world, you think nobody uses this, right? It is used out there, and think of things that are changing: bacterial growth, blood pressure, looking at electric bills. We can analyze football stadium with the retractable roofs now. Business, which you guys are in, that you want to look at the sensitivity of demand while we're changing prices. Automobile industry, as an impact happens, what happens with the airbag. Forensic science, where we can find the actual estimated time of death. And even musicians use this stuff. So anything that you have something that is changing, this is huge that you would use calculus for. So let's do some review on things that hopefully you kind of remember. Now, this is the point where you're just sitting there and you're staring at the screen and saying, Get your little portfolio out. Remember, your portfolio is going to be made up of problems out of that text packet and your notes. So it's going to show me that you took notes while watching lectures. So get that sucker out. Get some clean paper out, however you're going to put your portfolio together, preferably in a 3-ring binder, and let's add some notes to it. So let's have some review material here. We like graphs because otherwise, if we don't have graphs, we just have a pile of data and it makes no sense to us. But with a graph, we can analyze and see, oh, there's a spike, but man, things have really went down, and oh, it's jumped back up. We can really see what's going on, analyze our data, spot trends. And so we definitely like graphs. We start out with the basics of a graph, which is paired data, such as comparing sales at a certain time, comparing heights to weights. And these paired data in the math world we call XY coordinates. So this Cartesian coordinate system here is made up of our x-axis, our horizontal axis, and our y-axis, our vertical axis. Where if you're in the middle where they meet, you're at the origin or the point 0, 0. If you move to the right on the x-axis, that's positive. If you move up on the y-axis, that's positive. If you move left on the x-axis, that's negative. If you move down, that's negative. We call each one of these quadrants, and they're based off of, this is my XY data. So my X values are positive, my Y values are positive. If I'm in quadrant 2, my X now notice is negative, and my Y is positive, and so on. So you see graphs like this all the time, and I know you're saying, no, I don't. I never seen a graph that looked like this. Well, typically what you're seeing is only this quadrant 1, because we like for everything to be positive, right? Especially if we're in business. And so we typically just don't show these other quadrants. If I have data values, for example, my X could be a certain day, and then my Y could be dollars, then I could go and I could plot each one of these like -5, 1. says go 1, 2, 3, 4, 5 to the left because it's negative, and then up 1 because it's positive. 0, 3 says don't move in the x direction and go up 3. And I could go through plotting each one of these points. Okay, so just be sure and familiarize yourself that you're okay with plotting data. Because then what happens is after we plot data, we say, well, let's make it into an equation. And you got into linear equations with two variables, and we could write them in standard form. You probably don't see it a lot like this, that ax plus by equals c, but there's other forms that you're probably familiar with, where this a, b, and c, they're just numbers. So I could have 3x plus 5y equals negative 7. A solution to an equation in two variables is that ordered pair, the x, y. When I plug them in, it makes this equation true. For example, if I have 4, 3, that would certainly be a solution to this equation, because when I plug in 4, 3, the left-hand side equals the right-hand side. And so any solution set of an equation in two variables is the set of all solutions of the equation. Then the graph of an equation is the graph of its solution set. So when you see these graphs, it's all these xy data points, and then we assume it's continuous and we connect the dots. We know some things about graphs. We know about x and y intercepts. A y-intercept is when you didn't go up or down on the y-axis, so your y is 0. The y-intercept is where you didn't go left or right, so x would be 0. All right, and then we moved kind of forward with this, and we said, well, we can move these around, and you came up with that y equals mx plus b, which is our slope-intercept, and it's our y-intercept form. If a is 0, so that piece goes away, then we just have the graph of y equals something, which would be a horizontal line. If we let this piece equal 0, then of course we would end up with x equals, and that would be our vertical line. And so for example, the graph of x equals k, vertical, y equals k, just some number, would be horizontal and would look like this. So we can see y equals a value would be a constant, and x equals a value would be a vertical line. Well, then next they taught you y equals mx plus b, where the slope is m and the b is the y-intercept. Have you ever wondered why they used m for slope? I guess this kind of stuff keeps me awake at night, right? I mean, you might say, who cares? But why would they use the letter m? And this is kind of a funny story, because there's lots of reasons that people try. For example, to climb means monter, but that's in French. In the French, Descartes, he didn't even use m for slope. So it's one of these things that it just kind of happened. So a little bit of trivia there for you. So we can recognize the components of a linear function. My m is my slope, so in this case would be -4. And then my y-intercept would be 5. So this is a lot of times why they always tell you, solve your equation for y. And I always wondered why. Why do I have to solve it for y? Because if it's in this form, then I can see right away my slope, and of course I can see my y-intercept. And so now if I examine what does the slope really mean, and most of you have memorized the rise over the run, this y2 minus y1, x2 minus x1, or the change in y over the change in x. You're going to see this course, guess what, we're going to still deal with slopes, but we're going to write it more like this middle one, where these delta y over delta x are going to be read as the change in y over the change in x. So guess what? That's still the slope. We're still doing something you've already known how to do, but we're just going to make it look a little more mathier and nerdier because you're in an upper level class, right? But it means the same thing. The change in y over the change in x is still going to be our slope. So if I told you to find the slope of this following line and you had all these data values, you know you could pick any 2 points because this is a line and it's constant. You could pick any 2 points. I could pick 2 different points, and then I could find my change in my y over my change in my x, and I would get my slope. Properties of slope: if the slope is positive, that's probably good if that's your bank account, right? If the slope is negative, might be good if that's your cholesterol level. And then a zero slope, maybe a company didn't want to change anything right now. They just want to stay constant until the holidays happen. And so these values are important because we want to know if demand is increasing. Well, did you get a positive slope? Are profits increasing? Are costs decreasing? Are things staying constant? And so this is important that you remember how to decipher that number that you get when you get the slope. All right, so we got this whole deal with the slope, and then we started messing with equation of lines. So what if I multiplied both sides by x minus x sub 1, so those cancel, and what I end up with here is the point slope form. Meaning, if I know the slope and I know a point, then I can get my equation of my line. Remember this, write it down, put it on your formula sheet. The point slope form, y minus y1 equals m times x minus x1, where your x1, y1, that's your actual point that you have. Let's go a step further and let's solve this for y. So I take that y1 and add it to both sides. Now if I distribute this m, which is all, I'm just doing some crazy algebra here. If I let that last piece equal b, well then I get to the slope-intercept form. So all these different forms of equations, they're just different ways of writing, and these are linear equations of a line. They're just different ways of writing an equation. What's the big deal? Depends on what you're looking. One depends on what you have, right? If you only have 1 point in the slope, then this one might work a little better. If you actually want to know what your sales are before you even open the store, or fixed cost, that might be your y-intercept. So if we have a known slope and a point, I plug in my y1, which is 3. I plug in my slope, and notice this is minus a negative 4. And all I did was distribute the negative and negative. And from here, I can put this in any form. I can distribute 1/2 times x, 1/2 times 4, which is 2. I can put this in that general form. Remember that ax plus by equals c? All I did from this step to this next one is I multiplied every term by -2. Why would I do that? Because I can, right? It's algebra. I can do anything I want. But I did it because I don't like fractions. And I know you don't like fractions, right? So that's the only reason why I put it in this general form without fractions. Well, what if you have 2 points? Like we say 3 days ago, our sales were $2. 4 days ago, our sales were $5. What's the rate of change, because that's the slope, and then put this in the equation of a line. Well, if I have 2 points, I can find the slope, right? I take the change in the y's, the difference 5 minus 2, the change in the x's, -4 minus -3, and I get a -3. So guess what? With this data, the line's going down, right? Because that's a negative slope. And then from here, I can pick either point and do my y minus y1, so you can tell I picked this point, equals my slope that I just found, x minus a negative, don't lose these negative signs here, and then I distributed the negative, and finally I solved for y, so I can still see my slope's -3, and I also can see my y-intercept is -7. Okay, so we have this donut shop has a fixed cost of $124 per day and a variable cost of $12 per donut. Find the total daily cost of producing X donuts. How many donuts can be produced for a total daily cost of $250? Now I know you're all like me. That's way too many stinking words. That's why you don't like word problems. What I do is I try to look and see, what did they give me? They give me fixed cost and variable cost. My variable cost is my unit cost per donut, right? So my unit cost of 12 cents times the number of donuts. Fixed cost, you remember what a fixed cost is, right? If you don't, this should be on your definition page. A fixed cost is you're going to pay it regardless, right? That could be rent. You don't sell a single donut, guess what? You're still going to pay rent, the light bill, things like that. And so then from here, I can start plugging things in. It says producing X donuts, so I let X equal my variable. And then it says how many donuts can be produced for a daily cost, so I know I'm going to plug $2.50 in for my cost. And now I have an algebra problem. I want to solve this for X because this will tell me how many donuts, because the number of donuts is X. So I subtracted 124 from both sides, and then I divided both sides by 0.12, and I get my 1,050 donuts. Let's look at another example. At a price of $9 per box of oranges, the supply is 320,000 boxes and the demand is 200. So I can already see I have a supply and demand thing going on. At a price of $8.50, so the price has changed here. That's my change, and that's how you know when you're going to do something with a slope is you have a change. I want to find a price-supply equation of this form. Well, even though it's different letters, this is still y equals mx plus b. So I know I need to find a slope, and p is going to give me the price in dollars, where x is the thousands of boxes of oranges. So I go through and I say, what's important? What do I need? I'm going to do supply first. $9 supply, 320,000. I change my 320,000 into 320, and I'll just say on my x-axis that's in thousands. My 9 is my price. Then the change is if I go to $8.50 per box, then my supply is 270,000. So notice there's other information that I'm not using on this part. Well, if I have two data points, I have this is paired data, and I know I need to come up with an equation, and I know I need a slope, then probably I'm going to take those two data points and find a slope. So that's my first step. Well, now because you're in a business calculus class, if you were just in a math class, we'd say the answer is 0.01. The problem is you got to go to your boss and you're going to say 0.01, and your boss is going to say a penny? What does that mean? This is why we like our slope written as a fraction, because remember, it's the change in one variable over the change in the other. Well, what was this top variable? That was my price per dollar. And then this bottom was the number of boxes. So basically, you can see this is the change in price per box. And this is why we like to write these out as fractions. I can use the slope 0.01 and either point to come up with my equation. So I used 9, 320, there's my slope. I start moving things around and I solve it for P, and that gives me my price supply equation. I'm going to do the same exact thing for demand. So nothing changes but my values for demand. So I get my two new data points, but now I'm not looking at the 320, I'm looking at the demand, 200,000 and 300,000. Guess what? I'm going to go through the same exact steps. I'm going to find the slope. As we see, this is negative. So the demand, there's a decrease. So if I look at this, I can see that the price is decreasing per box. I can go through the same steps and find my price-demand equation by plugging in my slope and also plugging in a point. So from here, what would be interesting is to plot both of those. Graph both of these, meaning graph this equation, and just kind of see what's happening here. So the supply, I mean, you can definitely see what's happening. This is going up. Okay, my supply's going up. My demand's going down, which probably makes a little sense. If I have my number of boxes, the demand's starting to go down with my price. What are the meaning of the y-intercepts? In other words, over here, well, read your axis. Remember, number of boxes is x. So this says when I don't sell any boxes, guess what? That matches your fixed cost. 5.8 and then 10. So that's my fixed cost. No matter what, those are fixed cost. Could you find the intersection of these two lines? Do you remember how to do that? Set the two equations equal to each other. When you set my price-supply equation and my price-demand equation equal to each other, and you solve this for x, okay, so I did all my algebra to solve this for x. You should do that. That should be in your portfolio notes. Don't just copy what I have. You go through the steps. Add 0.005 to both sides. Subtract 5.8 from both sides. And then divide by 0.015. Then plug this back into both of these equations, and you should get the same value because we said that's where they intersect. And does anybody remember what that point is called? What's the meaning in business? I know it's where the two lines intersect, but do you remember what that point's called? Equilibrium point. So basically this says the price of a box of oranges tends towards this equilibrium price of $8.60 when the supply and demand are both equal. So it's important that you learn how to interpret your answers here. All right, so here's just a review of all the equations that we used. And this would be something I would put on my formula sheet. Definitely the slope-intercept, and the point-slope form. Those are big ones that you're going to use a lot over and over and over. So have them on something.